Good morning, good afternoon, and good evening for this webinar by Institute of Corrosion Midlands branch. We have an exciting topic today about CUI, corrosion under insulation, and management and predictive methodologies of managing it. We have two speakers today from the industry. My name is Praful Sharma. I'm the chair of Midlands branch. And happy to host this webinar today. Today we have two eminent speakers. There's a slight change in the speaker order. So we have Ian Coleman, who is from Dow Chemicals, and he's asset integrity expert. Could not make it today because of site plant emergencies. So as a replacement, we have Rene, his colleague, and a global expert on asset integrity and CUI management practices and NDT. So we are very happy to have Rene standing on behalf of Ian. So welcome, Rene, to this webinar of ICORR. And we have Phil Yule. He's speaking from the US. He's based in Houston. He's an expert on CUI monitoring technologies from corrosion radar. And we are happy to have him as well. So he will be talking in the second part of the webinar today about CUI monitoring, starting with Rene today. Rene, welcome to the webinar, and over to you to start your slides about and educating the attendees on CUI issues and problems and the best practices.
Thank you, Praful. You first have to tell me how to share.
Sure. So I think at the bottom there is a share screen, and then you can share your slides.
Okie dokie.
Yeah, you can go full screen.
Yeah, welcome everyone. Thank you, Praful, again for inviting me. I'm not able to share my video, so we have to do it this way. Yeah, my name is René Godry. I'm based in the Netherlands and close to the south of the Netherlands, close to the Belgian border, at the Terneuzen side. So I work for Dow Chemical, or Dow Benelux. I'm part of the Matrix Technology Center. They have a mechanical integrity team, a small team taking care of our global mechanical integrity and safety standard. Working for Dow for 38 years plus. So my background is NDT and mechanical integrity. I'm a member of the Global Mechanical Integrity and Safety Steering Team, and we come to the GMIS, how we call it later on. And I'm also the leading the non-destructive testing and implant inspection TST, and the TST stands for Technical Solution Team. And that is a group of about 20 people, SMEs around the globe, in the field of NDT and implant inspection. So, introduction to CUI. Yeah, this is for me more a story of of my life, more or less. Within Dow, many years ago, I think it was around 2008, we had quite a big incident, and that completely changed my life of working and my life of my way of working and basically my complete life. Because we had an incident at that time, and I was part of the root cause analysis, and that incident had to do with the COI. So within Dow, we had quite a good performance of process safety incidents, but we saw some issues with especially piping circuits and piping systems where we had COI issues. So we had already a mechanical integrity program that was started in the 60s. That program is called the Mechanical Integrity and Safety Standard. In 2001, we had that one already implemented, and for COI that was more or less based on the rules within API 510 and 570 for piping. We saw in the early, let's say 2000, that we had some leaks and close calls, and that pushed us to upgrade our mechanical integrity standard. So we have updated that one in 2004 with more guidance. Although we had quite a significant near miss, what I said around 2008, we had a certain failure of an 8-inch high pressure hydrocarbons line, which was caused by corrosion under insulation. On the right-hand side, you see a picture of that failure. We were quite fortunate because it was a full bore rupture, and this pipe was bent more or less in a way that it choked the release of ethylene and hydrocarbons into the plant. So we were quite lucky with that one. That was a pipe which was 30 years old. So we started the root cause, and we saw that there were some issues going on with the inspection of this. So the pipe was 30 years old. It was a 20-inch scheduled carbon steel. It was a regeneration line from filled with cracked gas for one of our ethylene plants. Due to the regeneration service, we had several operating stages, and that was a bit overlooked. So the regeneration condition was about 220 Celsius for about 20 days. For 1 day. Then it was on stream for 20 days, and then it was operating at -17. So that is outside the COI range. Then the regeneration time was only 24 hours, 1 day, and that was on 220 degrees C. And then it was standby for about 19 days. It looks like that a bit. You can see that if it operates in the low area, -17, or let's say 0 Fahrenheit, it's outside the COI range. And if it's operating at the regeneration step, it's in 220 C or 430 Fahrenheit, which is also outside the COI range. So it was not very well understood by the inspection department why it failed, because they thought it was only operating in 2 stages, and that was -17 and 220. So they completely forgot that it was also in standby mode in ambient temperature, and then it is in ambient temperature about 20 days, 20 days, but then it's in COI range. So the communication between operations and the inspection department failed in this one. So what you see here is the location where it failed. You will say, okay, it is not insulated. No, this was after we repaired it, and we did not put the insulation back on at that time. And you see there is a transition zone over there where you have very cold surface where it's iced up. You can clearly see that now. And that you have an area which is in transition zone, which is not in COI, which is in COI range, which is not iced up. So this part around that valve over there is constantly around ambient or a little bit less than ambient, but always in COI range. And that part that failed there. So we did some root causes, of course, root cause analysis, and we found some root causes. There are only 2, the major ones, which I'm showing here. So one of the things was that the inspection was not done in a proper way. Not according to API 510, 570. So it was piping, so it was 570. And what we also saw was insufficient insulation removal, or NDT, in the inspections. The other one was operating conditions. What I already said, they were not very well understood. The inspection department thought that it was only in let's say, operating outside the COI range, in the hot part and in the cold part. And it was not very well known that it was also in standby mode for a very long time. So the actions coming out of that RCI was training of all the involved disciplines, not only the inspection personnel, because they know more normally how to do a proper inspection for COI, but also the operation personnel and the maintenance personnel. So what we did was an extensive training of all the roles and explain what the roles and responsibilities are of the different groups of in the organization. The second thing what happened after that, there was a COI emphasis program. So we started redoing all the COI inspections on critical equipment. What we did is, as a maintenance tech center, we had global oversight, and we also reporting and keeping track of all the inspections of the critical systems in around the company. After that, we started our what we call GMS audits, the Global Mechanical Integrity and Safety Standard audits. So we went to all the facilities more or less and looked, did a thorough audit and looked at every details on the COI inspections. And that is basically, how did you inspect it? How much insulation did you remove? Did you do the proper follow-up when you found something? So one of the things was that what we implemented is this, let's say, strategy on hazard rating and the classification of our piping system. So from the hazardous, different types of hazardous chemicals, you will fall in a class 1, 2, and 3, and that is per API. And then it will tell you what are the inspection frequencies. That is for class 1, 5 years, class 2, visual 5 years, and NDT 10 years, and for class 3 is it 10 years for the visual and NDT. And we also used the API 570 tables on dictating how much insulation you have to remove on the suspect areas. And there is also what you see on there is the list of the suspect areas which is given in API 570. So what we said, if it's a class 1, you have to remove 50% of the suspect areas and 75% of the damaged areas. And this is different for the class 2 and 3. But we are following API 570 for that. So about CI management, yeah, what I said, it is not only a Dow thing. It's a globally within our industry in refineries and process industry. You will find it everywhere. We have insulated materials, especially for carbon steel and stainless steel. For carbon steel, you easily see it. For stainless steel, it's a little bit different, but you have stress corrosion cracking often. On the right-hand side, I give an example of how it looks like. But this is one example. But if you look on internet, you will see that you will find a lot of issues which you can show, which are shown in if you just Google it, corrosion under insulation. So we are not let's say, the only ones which have this issue. Corrosion is hidden, so it's not easy to find. Sometimes on the outside, the insulation looks quite good, but if you remove the insulation, you can be shocked depending on how the operating conditions are. It's better that you find the COI before it will find you. So you have to have a thorough inspection program to manage the COI threat. If you look to the factors of COI, you have the type of insulation. It makes a difference if you have a glass foam or if it's a mineral wool or asbestos insulation. That makes a difference in how wet it can be and stay. So that part is influences heavily the behavior of COI. Then the service conditions, if you are close to, I would say, a cooling tower, where you have cooling tower drift, that also will influence the behavior of COI. Then coating, especially the coating quality. If you have a good coating quality, it can last quite a long time before you see COI. So the coating quality checks are quite important to prevent COI. What we have seen is if you do quite a good job on quality control of your new plants, it can be there for 20, 25 years before you see any COI. If you don't take care of your coating quality, it can already start with COI in a few years. Then about the design part, it makes a big difference what kind of jacket you put on and how you put it on, and do your quality checks on that. And then, of course, also the climatic part. We see quite a bit of difference if you are close to the sea, like US Gulf Coast or in the Netherlands or in Spain, or that you are in Canada. That makes quite a big difference. Weather is drier and you have less COI going on over there. So what we use today is the industry standards to keep, let's say, to be used for our inspections. And so basically everything what we do is based on API 510 and 570. We also use the other best practices like HOIS to manage and just to manage the COI and to set up our inspection strategies. So in general, those strategies are about the inspection timing, how often you will inspect the equipment, and already told the transmit on the classification of your piping. If piping is in class 1, it's different than the class 3. But also the scope, the percentage of susceptible areas. I already mentioned that in that table from API. And of course, the action taken when corrosion is found. If you find something, the rule is that you have to extend the inspection to remove more insulation till you have sound material or sound coating on it. And sometimes we see that we do not remove that enough material, or let's say enough insulation, but that's critical in managing your COI. Yeah, the excess of your inspections are not always easy. It's not always close to the ground, so you have to build scaffolding, which is quite expensive, and that makes it quite expensive and more complicated to do your COI inspections. We of course have NDT tools like guided wave to help us, and other techniques to lower the cost of inspection. I'll cover this part. So the future challenge is, and I think it's in general in industry, we want to reduce the risk of COI, and we are looking for new technologies to do that. And one of the technologies, of course, is sensor technologies, that those sensors will tell us if there is COI going on, or the risk is increased for COI, depending on the outcome of those sensors. So we want to use that data coming out of those sensor technologies to optimize our inspection strategies. And that is more about the timing of the inspections, but also the locations where to inspect. So ideally, and that's hopefully in the near future, but that we only would inspect places where sensors will tell us where to inspect, depending on the outcome of, let's say, the results of those sensors. So we have to adopt the technology and methodology in the industry standards, and we are looking for that. I think that is something that has to be done in our standards. How can we incorporate sensor technology and let's say into the standards like API or other standards? So that was basically what I had to tell Rafał.
Thank you, Rene. Thank you for a very good, insightful presentation. We have some questions coming in online, so we'll take it at the end. So with this, I pass the ball to our second speaker, who is also a COI monitoring expert, one of the sensor technologies which Rene, you mentioned the use and upcoming use of sensor technologies for COI management, and that links very well to the second part of the presentation, which is our colleague Phil Yule. Phil, over to you. I know you are speaking from Houston. Please share your slides and introduce yourself.
No problem at all, Praful. Thanks for the invite today. Can you hear me okay?
Yes.
Perfect. Let me just share my screen. Hopefully you can see that.
Yeah.
Okay, great. Well, good morning, good afternoon, and good evening to everyone that's joined today. And thanks for the introduction, Praful. Just a little bit about myself. I'm with Corrosion Radar. I'm the America's Business Development Manager. We're one of the sensor technology providers that Rennie touched on in his presentation. Just a little bit about myself. 15 years in oil and gas, started my career 2007, been in corrosion, been in the corrosion industry since then, really starting in the internal corrosion management side of the industry, with recent experience in external corrosion cathodic protection systems here in the US in the midstream market, and most recently now specialising in CUI monitoring and the use of sensors for predicting CUI risk. So just a little bit of a background on myself. So really what I want to touch on today is just really to follow up on Rennie's presentation, the great presentation about the problem or the risks that are associated with CUI in the industry. CUI, I'm sure everyone on this call is very familiar with it. It is a global problem, it's an industrial problem. So I really just want to touch on today is some of the new technology that's available for monitoring and predicting CUI risk in the industrial applications. Rennie touched on this as well. So, CUI is very hard to detect. It's a hidden problem. There are I guess techniques that are used just now. This is a new technique that I'm going to touch on, the permanently installed sensor deployments. The techniques that are used currently tend to be very reactive, which can lead to higher costs when you're reacting to the problem rather than identifying it ahead of time. There is a stat out that 60 to 70% of routine visual inspections actually find no CUI. So that's a very costly exercise when you think about labour, materials, and time that's spent on that technique looking for CUI. And what we hope to do with the type of sensors that I'll talk about today is really help optimize and make that more efficient by using sensor technology to predict where and when the CUI problem exists. So really the need on the slides here is, when and where is the risk of corrosion or corrosion under insulation? Can we pinpoint the hotspots, identify the hotspots that are hidden underneath the insulation and the jacketing, the cladding? Obviously the pain, it's a very costly problem, very reactive at the moment, the management side of it. So it's obviously quite a costly exercise, and obviously the biggest concern is the safety risk. It's a hidden problem. I think Rennie touched on it with the incident at Dow. They had that near miss incident there where there was no real visual signs of CUI taking place. It was hidden underneath that insulation and jacking. So the opportunity really that I want to talk about is moving towards a sensor approach, a predictive, real-time, permanently installed sensors that are used to identify where the CUI risk is and help optimize and make things more efficient on the inspection side. So I'll just quickly touch on CUI monitoring. Try and keep this as neutral as I can. I know it's an ICORR event. But talking a little bit about the sensors that we have. Really what the sensors are for is the sensors are permanently installed on the asset or the application, which allows you to have continuous monitoring of the asset for CUI risk. So they're permanently installed on the asset itself. It gives you comprehensive coverage. So it's detecting the CUI risk across extended areas, complex geometries, vessels, piping systems, columns, nozzles, tanks, etc. So it gives you a good coverage, and we can cover the vessel and the asset full coverage for full monitoring. We talked a little bit about the predictive maintenance. That's really where these sensors come in, is being able to predict where and when CUI is taking place. So it's really catching the CUI problem at stage 1 instead of the critical stage 5. So identifying that there's a problem, and being able to react to that problem and mitigate that problem that you found on the asset or the facility. The sensors themselves are giving you a CUI risk. I'll talk about that in a few slides as to how that's calculated. But also these sensors are identifying the early stages of CUI. So when there's moisture ingress at locations, it's your first sign that there's potential for CUI to take place, and I'll touch on that in the next slide. Really, this CUI monitoring sensor technology is used as your CUI, it's part of your CUI toolkit, and so it's part of the inspection program, allowing you to be a lot more predictive on the maintenance side rather than reactive to CUI issues that you find. So a typical CUI monitoring system architecture, obviously to detect CUI, the sensors have to be deployed underneath the insulation and cladding. So really probably the most optimal point for installing the system would be during a routine turnaround or CUI inspection where the insulation and the cladding has been removed. So you can then deploy the sensors on top of the coating underneath the insulation, and it's monitoring that void in the problem area where CUI exists. So for our sensors in particular, we have a corrosion sensor and also a moisture sensor, and they're both deployed side by side. As I said, they can be deployed over long ranges or large areas. And they're continuously communicating through a wireless node that is on the facility itself. In our case, this is using the LoRaWAN wireless protocol, but there is also a Bluetooth download option as well, if LoRaWAN is not available on site. There are obviously other wireless protocols out there, but our system at the moment is using the LoRaWAN infrastructure that's in place on many of the facilities out there globally. The actual sensor technology, the corrosion sensor itself, is using electromagnetic guided radar. So really the node activates once a day, or as often as you would like it to, but we see with most applications at the moment, it's once a day. It will send a single signal down that wire looking for defects on the actual corrosion sensor itself. So the sensors will pinpoint where the corrosion is or where the moisture is taking place. Trying to find my pointer here. So it will identify along the length of the sensor the exact location of where the moisture ingress is taking place, where there is the potential for corrosion to take place as well. The data itself is transferred back or integrated back into a dashboard for visualization and analysis of the data that comes back from the sensors. And I'll touch a little bit on that in the next few slides about the dashboard and how that's visualized. But this is really just a typical CUI permanently installed monitoring system architecture from the deployment underneath the insulation to the communication back to the dashboard for the visualization, the analytics that are done, and for you being able to use the data to make informed decisions about your CUI program. I forgot to mention as well, I mean, this can obviously be a standalone system. but we can you can also integrate into your system that you have in place on your facility. To talk a little bit about the dashboard for this particular system, really what we're aiming to do here is reduce the risk of CUI. As discussed in the first few slides, it's a global problem. I don't think there's a silver bullet at the moment to manage CUI. There's a lot of techniques that are out there for CUI management, and permanently installed sensors are part of that CUI toolkit. Really to help you predict where and when to act when it comes to CUI risk, and to optimize your inspection scopes and your turnarounds, etc. So really, this is an example of the dashboard, how you would visualize. I talked a little bit about the sensors identifying the hotspots for corrosion under insulation. So you'll see on this 3D render here, it's correlated back to the sensors. So the raw data on the top right, and this is the raw data from, they both look very similar, from the moisture or the corrosion sensor. I think you can see here the heat map, it's identifying that there's a problem around the 4 meter mark, or around the 3 meter mark. This is the date axis here. So, showing on the 3rd of January 21, something had occurred on that asset itself. Whether it was moisture, corrosion, I'm not too sure with that data point itself. But you can see it's picking up, the heat map is picking up that there's either moisture present or there's corrosion beginning to take place on the sensor at that specific location. So that's correlated back to the 3D render, which identifies exactly on the asset where there's moisture present, and also it will give you an output of low, medium, and high risk of CUI based on the data that's coming back from the sensors themselves. So the data from the moisture sensors and the corrosion sensors, but it's also incorporating the actual physical asset data as well. So the type of asset that's installed, the type of material, the age of the asset, the inspection history, the type of coating that's being used, the quality of the coating, all that information is gathered in the dashboard. So along with the data that comes back from the sensors themselves, that's then put into an algorithm which is based on either the DNV CUI risk standard or the API CUI risk standard. And that's where the output comes from to provide you with a low, medium, or high risk of CUI. So it's taking the raw data in from the sensors. It's also looking at the physical asset data that's available, and it's pinpointing where there is a risk of CUI, whether it's low, medium, and high, and where there is moisture present underneath that insulation and cladding. So what that's really allowing you to do is visualize on the assets where the problem is, helping you to optimize your inspection scopes and your inspection frequencies as well. So being able to use these types of sensors should allow operators to either reduce the scope of the inspection that takes place. An example of that is, you could have a routine inspection that takes place every 5 years, say, with 100% strip of the insulation and cladding. By using these sensors, you will be able to identify, like as an example on the storage tank here, that 80% of the asset is dry. It's not showing any risk of CUI. Can you pull down that inspection scope to perhaps strip 30%, 25%? So a huge cost reduction when it comes to everything from labor to scaffolding to materials. It can really be a huge cost benefit to the operators. So just to touch on that, we talked a little bit about the costs. We have run ROIs and cost analysis with various operators, and we do, by using the sensor technology, there is the potential to reduce costs by up to 65% when you take into consideration the reduction of scope, the reduction of intervals, the labour, the materials that are involved in the inspections that are done on larger assets like the column that's shown there. It's a huge cost in scaffolding, etc., to do these inspections. If you can reduce that strip scope by 25-35%, and that's really where you see the cost benefits of using the permanently installed sensors to monitor for CUI risk. And based on that, it's really looking at the difference between reactive maintenance, predictive maintenance, and preventative maintenance. So this is just a small table that shows how, when you're working to a reactive maintenance philosophy, I guess, there are very high repair costs after the failure occurs. So you're really waiting for the failure to occur, and then you're experiencing quite high repair costs to the actual asset itself, but also the downtime to the facility as well. So unscheduled shutdowns, etc., that just adds to the costs of reactive maintenance. On the preventative side, obviously your inspection cost increases quite considerably, does reduce the repair costs, obviously by inspecting more, but obviously the cost of inspections increase. This also touches on the initial slide where I talked about the kind of costs that are involved in the visual inspection side, where 60 to 70% of visual inspections actually don't find CUI. So that's a real cost that could be saved by using these types of sensors to identify where the CUI risk is. On the predictive side, that really reduces both. So it reduces the repair costs compared to reactive maintenance, reduces the inspection costs compared to preventative maintenance. There is obviously an upfront cost to get these sensors in place, but once they're in place and they're permanently installed, they're there until the next scheduled inspection takes place. And even then, those sensors can remain in place if there's been no degradation to the sensors themselves. So they're really there for the life of the asset. And if the sensors need to be replaced, they can be cut and spliced if there's damaged areas due to corrosion underneath the insulation. This map just really shows the deployments that are out there that we're aware of. So across the globe there is CUI permanently installed sensors being used on various different applications, from storage tanks to vessels to piping systems to offshore facilities, onshore facilities, petrochemical plants, refineries, etc. So there's a wide range of applications, which just to give an idea that the technology is being used. And it's being used around the world in various different applications. So this is really my last slide, and just the benefits of using CUI permanently installed monitoring. Looks a little bit blurry for some reason. Apologies for that. So really moving to a predictive rather than a reactive approach to CUI. Benefit of that is obviously reducing the costs that are associated with reactive monitoring or reactive inspection when it comes to inspecting things that don't have CUI problems, to reacting to or having to shut down facilities or parts of your asset due to finding a CUI problem that wasn't visible, obviously with it being hidden underneath the insulation and cladding. It's also a good quality assurance on the insulation work that's done. So if you do have a turnaround or you do have a routine inspection that takes place and the insulation and cladding is removed, having the sensors in place will identify very quickly if that insulation and cladding has been reinstalled correctly. The moisture sensors will very quickly pick up if there's a storm goes over the facility. They will pick up very quickly that moisture is getting in there, allowing you to react to that quickly, fix the problem instead of identifying it, 3-5 years down the line when you open that insulation and cladding up and realize that there's been a hole in the insulation and cladding from day one, causing major CUI concerns. Optimizing inspection cost, it's really the benefit, the main benefit is to, use these sensors to predict where and when CUI, or where and when the CUI is going to take place, and what the risk level is, based on the sensor data that's coming back, along with the historical asset data that's used with the CUI risk algorithms inside the dashboard. So it's really allowing you to potentially decrease inspection frequencies, but very likely optimize your turnaround scope. So instead of stripping 100% of an asset or a vessel, by using the sensors, which will show or could show that 50% of the asset is dry, there's no CUI risk there, you can really reduce those scopes and save a lot of costs when it comes to materials, labor, scaffolding that's used to strip these assets during the inspection. And ultimately, the main goal of CUI permanently installed sensors is to reduce the risk of CUI for loss of containment for safety. So as we know, CUI is a global problem, and it's found across various different facilities and types of processes. It's a hidden risk, and by using CUI permanently installed sensors, you'll have better visualization of where the risk is on your assets, to allow you to make really smart choices with your inspection scopes. And with that, Praful, that is my slides complete.
Thank you. Thank you, Phil. It was a good set of presentation, and let me start my camera again. I think that was a great set of slides. Thanks, Renee. Thanks, Phil. And now we are in the question and answers session. Obviously, linking back to Renee's slides, which is more about CUI problem and CUI management practices, and then linking to Phil's slides, which are more about the new method, which is coming out, is in addition to inspection, you have monitoring, predictive monitoring. So we have quite a lot of question and answers. We have about 18 minutes to cover some of them. If we are not able to answer all of them, we'll get back to the question on the emails. So we will reply back on the email. So let's go to the question and answers. I believe the first question, which came in really early, was in the chat window. It's about, let me read it out, and I believe this is Renee, this is for you. Can you please advise best practice to know if hot hydrocarbon piping that are steam traced and insulated suffers from CUI? And when steam tracing leaks, it may cause CUI, but we cannot know when it leaks as it is insulated, or if it is minor leak. Renee, would you be like to answer that question?
Yeah, basically we treat it the same as a normal inspection, but if we know that it is steam traced, yeah, then most of the time you see that you have to remove more insulation. What we do, remove more insulation for the CUI inspection. It is not always that we do inspection, let's say removal of the lagging of the insulation. It is all profile radiography, or it is guided wave. I mentioned also, if we have large diameter piping, we use pulse steady current for screening. So we use some screening tools. We do not treat traced piping differently, although we see more issues with traced piping. So we normally remove more insulation of that.
Okay, thanks. Renee, second question, again from the same person. When TSA is a better choice over other coatings, and please share examples.
We are using TSA only for equipment which is in cyclic service, like one of the examples I showed, the first one, where we have equipment which goes into the COI range and out of the COI range, and where we have sweating service. That are at this moment the main application for TSA.
Okay, and what are the bad aspects of using TSA?
We have not seen a bad aspect till now. We started this, I think, maybe 5-6 years ago, for our dryer sections, and the TSA is still okay.
Okay. Another question, why you don't consider RBI for inspection timing?
Yeah, I forgot to tell. We have sites and plants which are under RBI, and we have still several sites which are not under RBI. So we use the condition-based / time-based approach for that, which is based on API 570, the tables I showed. For the RBI sites, they just follow the RBI strategies for COI.
Okay. Thanks. Now I will go to the question and answer section altogether, because this particular one was in the chat window. So question and answers. Is the presentation recorded and will be available to see later? Yes, the answer is yes, it will be. Another question is LRUT a feasible option for CUI? Rene, I believe this is for you.
Yeah, if you say long range UT,
Yes.
it can also be a guided wave. It is also long range UT, but normally the long range UT does not have that travel that far as guided wave, but it is an option. We use it for especially for touch point corrosion and that kind of things under the insulation. So it is an option to be used.
Great. Next question is, what type of sensors are available and how can the data they produce be interpreted? I believe, I'll go to Rene first and then Phil.
Oh, sorry, can you repeat the platform?
What types of sensors are available and how can the data they produce be interpreted?
And then you mean the sensors like corrosion radar and
Yeah.
the other ones.
Yeah.
Yeah, I think Phil just gave a whole presentation about that, and that's how we use the ones for our systems, which are highly corrosive. So the ones we use is, let's say, the corrosion radar system. What we use is around those, the same equipment what I gave as an example. So the dryer systems, where we have a highly corrosive environment, and that are the ones we use till today.
Great. Thanks, Rene.
Oh,
Phil,
yeah, there are other systems on the market.
yeah.
So there is a JIP which are testing those sensors. So we are basically waiting till the outcome of the JIP to see what other sensors are available and how they perform.
So my question, Rene, is which is that JIP?
The Cirrus JIP, where you are part, let's say, what corrosion is part of.
Thanks. Phil, do you have any comment on this the data interpretation from the sensors?
Yeah, I mean, I think just from my side, I'm looking at the Q&A. I think David actually jumped in a little bit later to say his question had been answered. So hopefully the presentation gave him the answer that he needed. But just to say, from our side with the data interpretation, that's the sensor data that comes back. Touched about the data that comes from the sensors along with the physical asset data, as well as that's in an algorithm in the dashboard that provides the CUI risk assessment and identifies the hotspots on the asset. That is something that's reported on quarterly. So there's a quarterly report that goes out for the systems that are in place, where you can identify the presence of moisture, if there's corrosion being picked up on any of the sensors on the asset. So that's something that can be provided by the product provider.
Thank you, Phil. So Rene, next question is for you as well. What is the general experience with spray applied insulation instead of lagging? Pros and cons.
Yeah, we don't have a lot of experience with that. I know that we have some storage tanks and some columns where we use it on. What I understood is that the insulation properties are not that good as, let's say, if you use 4-inch or 6-inch normal insulation. So you cannot apply it on all equipment. And what I also saw is that if you have internal degradation with those sprayed insulation, you cannot use the normal UT measurements, or you have to remove those layers of sprayed coating, and that's not really what you like to do. So that's I would say that's a con for that normal UT cannot be used on that.
Okay, thanks. The next question from Sunday Samson is so I think this is for Phil. Phil, any limitations in terms of sensors in large diameter tanks, like temperature, say minus 50 degrees Celsius to 200 degrees Celsius, in terms of CUI monitoring using sensors?
No, there's no real limitation with the sensor. A typical sensor deployment with the node or the transmitter that's used. So a single node can have up to 150 feet of sensor attached to that node. If you have a larger asset, you can just use multiple nodes, multiple sensors that are all tied back into one system. The temperature range on the sensors is anything from negative 190 Celsius all the way up to 300 Celsius. So there's a really wide temperature range that the sensors can be used on as well. But there's no real limitations to asset type. If you have a larger tank, you would just deploy multiple nodes with multiple lengths of sensor that would all tie into one system.
Thank you. Another question for Phil and from Ahmad Isa. What is the sensor dimension and shape, and how it can cover? How it can cover?
Yeah, so the sensor itself, it's kind of hard to describe, but it's if you imagine just a braided wire, so it's a very thin wire that's used, very flexible. It can be deployed on complex geometries, etc., on assets, so around nozzles, around tanks, around columns, etc. I think I covered it in the last one. It's 150 feet per transmitter. But if you have a larger column or vessel, it's just multiple transmitters with multiple sensor sets that are used to cover the full coverage of the asset.
Cool, thanks. Another question for you. Can the corrosion sensor predict corrosion rate?
It is something that is being worked on, but to I guess really clarify that point, it's the corrosion rate of the actual sensor itself. So it's not detecting the corrosion rate on the asset, but it is correlating that data when we're looking at the dashboard analytics that are sent out and the reporting that's sent out. There is a corrosion rate, but it is specific to the sensor. It's not telling you a wall thickness or a rate of loss of the asset. It's just giving you an indication that there's a corrosive environment there and the rate of corrosion in that environment based on the sensor itself. But that's something I could follow up with more information.
Question from Frederick is the sensor installed during fabrication, and what if the equipment already in operation?
So I touched on that a little bit in the presentation, where there's two ways that the sensors can be deployed. Obviously, they have to be underneath the insulation and physically on the asset. So greenfield applications, that would be done during the construction and commissioning stage. Perfect opportunity to get the sensors in at the start of production. If you have an older facility, really where the operators have been doing the installs is during either daily maintenance schedules where they're doing CUI inspections and they're removing the insulation and cladding, doing the blasting and the repair work. It's a good opportunity to get the sensors in, or during turnarounds where the insulation and the cladding is removed for the turnaround. Again, that's a perfect opportunity to get the sensors deployed.
Cool. A lot of questions on the sensors. Another question is sensor only monitoring for moisture? Can it also monitor ionic concentration in the area? Will sensor provide any information about the coating status, since as long as coating is intact, corrosion will not take place?
So yeah, I mean, I've touched on that a little bit. The moisture sensor is picking up moisture. I'll come back on that other question. I'll need to dig into that a little bit to come back, but I'll definitely do that. But it is picking up moisture presence. The coating side of it, and that's really where we talked a little bit about the dashboard, where the dashboard takes into consideration the physical asset itself. So the materials that are used, the temperatures, the type of coating that's in place, whether that's a TSA or another type of coating, and and also the quality or the condition of the coating as well is part of that algorithm and part of that risk assessment that's calculated. So it's taken into consideration the data from the sensors itself, but also the physical asset data as well. But you can definitely follow up with more information on that question.
Thanks. I believe there's a question for Rene. This question is, say, after applying TSA, can you inspect the base metal with UT, considering that TSA is on? Rene, you are on mute.
Okay, sorry, yeah. That's an interesting one. It depends a bit on what type of TSA and how it's applied. But normally you can do UTs. You have to do some preparation of the surface before you can do it. But it could be they have to flatten the surface a little bit. That you have get rid of the roughness of the TSA. But normally you can do some UT on it. But it's case by case, I would say. It is not really easy to do crack detection. If you have cracking of the base material, that is, I don't know if it's possible to do that. But I know there is an Hoy's program that is looking into this. I think that is already finished on it. And what I understood is that for thickness measurements, yes, it's doable. For crack detection, it's very difficult.
Okay, thanks, Rene. I think there's a question for Phil about the sensor. Is the limitation of the sensor is specific to its installed position, that is fixed on X and Y axis?
I'll maybe follow up with who asked that question just to get a bit of clarity on the question itself. But I'll follow up with that one.
All right. Okay. Sure.
Understand a bit more what the question is.
This question is from Richard Lindley.
Okay.
We'll follow up on the questions on that. So, Richard, your questions will be answered. This question is on, again, Rene, to you. Are you using sealer over TSA when applied to mitigate CUI? What is the thickness used?
I have to check, but I don't think we are using a sealer. But I have to say, if you use a sealer, it's easier to you take your UT measurements on it.
All right.
But I think for the applications we had, I'm not sure if we have used a sealer.
Sure. All right. I think there are some more questions. I think we will have to get back on later on, but I have one last slide for that to be shared. Now, obviously, this is an important topic. We have CUI and Corrosion Under Insulation. Institute of Corrosion endorses one course which is on CUI, which is run by Fleming Evans. We have great experts who do this course, or as trainers, Claire Watt and Steve Patterson. But this is a great course. We would like to tell our audience that if you want to be having a deep expertise in this topic, then this is a great course for live virtually online as well. Next one is scheduled is in April. So with that, I would like to thank our audience as well, our speakers, Rene and Phil. Thanks for a great session today. And
thank you for the invitation, Pavel.
Yeah.
Thanks for coming. And with that, we close this webinar, and all the attendees will send the recording of this webinar. And if you need certificate of CPD, please reach out by email, and we'll give that. Thank you, everyone. Thank you for attending today.
Thank you. Appreciate it, Prof.
Thank you. I appreciate it.